Okay, welcome to core video 2. So in this video, we're just going to talk about language. So especially with quadratics, a lot of questions are going to ask about roots, zeros, and x-intercepts. One idea with three languages going to kind of differentiate between the three. So our goal is that we can just connect these ideas, see that when they come up, a question is asking us the same thing, just in different language. So our hook is we have a function, f of x equals x minus 2 times x plus 5. Question is, are these three questions asking for the same thing or are they asking for different things? So find the roots, find the zeros, find the x-intercepts. So let's start by looking at this question. You've thought about it a little bit. Let's take a look at it. So our question is, for the function f of x equals x minus 2x plus 5, we want to find the roots, zeros, and x-intercepts. And again, we are asking ourselves, are these the same thing, asked for different ways, or are they actually different things? So to start, a little prompt is going to be what output value puts a point on the x-axis. So if we're thinking about a little Cartesian coordinate here, where would we be? So if we're on the x-axis here, that means we are somewhere here, here, or here, or here. For all those, we're going to say y is 0. Our output value is going to be 0. So to put a point on the x-axis, we know our output has to be 0. So if we start with our function f of x is x minus 2 times x plus 5, we know our output f is going to be 0. So 0 equals x minus 2 x plus 5. So now let's just solve this, right? We're already factored. Let's just solve this. So now zero principle says x minus 2 is 0 or x plus 5 is 0. So that's going to give us x is 2 or x is negative 5. So those are answers to the equation. But now the question is, are those all the same? So roots, zeros, and x-intercepts. So let's kind of go through these one by one. So let's look at the roots first. So roots. So when we're asking about roots, we're going to say straight up, so x is 2, x is negative 5. And those are the roots. So roots solve the equation f of x equals 0. So they solve, I'll just put this in green actually. So they solve the equation f of x equals 0. So there's our roots. Next up is zeros. So let's look at zeros. I'll put them right here. So zeros. So our zeros here are again x equals 2 and x equals negative 5. So those are the same answers. What the zeros do is the zeros tell us that because f of 2, if I input 2, I get 0 back. If I input negative 5, I get 0 back. That's why they're called zeros. Done. Now notice those two are both just the x. It's just, here's the answer, x. I don't care about y at all. Now, for the final one, x-intercepts. So I'll move over here a little bit. X-intercepts. Well, x-intercept is graphically where we intersect the x-axis. These point, it's a point in space. So the x-intercept needs that coordinate pair. So we need to say x-intercepts are going to be, so for this one, they were 2, 0, and negative 5, 0. So I need that kind of whole point. It's not enough to just state the x value. I need the x and the y. It's a point. Okay. So our big kind of takeaway there is the roots and zeros are both x values, where the x-intercept is actually a point in space. Okay. Time for you to do one. So yours is g of x equals negative x plus 3 times x minus 1. Find those zeros and the x-intercepts. And again, knowing that zeros and roots are really just the same thing. Okay, try it. And here you go. So here's your answer. So you can see zeros are negative 3, 1, and the x-intercepts are negative 3, 0, and 1, 0. Now, something to note is just look at this negative. So this question had this negative in front. What did it change and what did it not change? So think about that, and then we'll talk about it. Okay. So the negative we know changed the direction, right? So a negative leading coefficient is just going to kind of change. So am I going to look like this or am I going to look like this? Am I going to open up or down? Notice that it didn't actually change our zeros or x-intercepts at all. It's going to change basically everything else but the quadratic, but not the zero because because the 0 is that y is going to be 0, right? So positive and negative doesn't actually matter. It doesn't change those points at all. It will change things in later videos, but for now, it does not change the root behavior. It does not change our x-intercepts. Okay, let's look at another one here. Oh, get rid of that. Okay, here we go. So another one for me to do. So question says, hey, find the x-intercepts of h of x equals x squared minus 6x plus 8. Now this sounds like graph language. So our question again is, if the graph is on the x-axis, what must h or y or h of x equal? So again, x-intercepts is really telling us right away that y is 0. So when I have my function h of x equals x squared minus 6x plus 8, if I'm at an x-intercept, that means y must be 0, so I can just chuck 0 in for the output. So 0 equals x squared minus 6x plus 8. So from video C1, I'm just going to solve this by factoring. I can see really quickly, I can factor this into x minus 2, x minus 4. Zero principle says either this is 0 or this is 0, and then solve. So x is 2 or x is 4. Now this question specifically wanted the x-intercepts. I didn't care about the roots. So I need to say, okay, so my x-intercepts are going to be 2, 0 and 4, 0, right? Make sure I include those coordinates, and that's it. So you can see an x-intercept question is just saying, hey, the output is ultimately going to be 0. Okay, so one for you. So find the zeros and x-intercepts of p of x equals 2x squared plus 5x minus 3. So I want you to solve first, decide which answers are x values and which are points. Okay, so take a second for that and we will come back for it. Okay, so here you go. So you can see we solved it out, a little bit of factor in there. We got x is 1/2 and x is -3. So again, distinguishing between, is that an x-intercept, is it a 0? And that's it. Okay, so one more little contrast to look at is we have these two functions. So r of x equals x plus 4 squared, and s of x equals x minus 1 squared plus 3. Number of solutions. So just a reminder about quadratics. We have two ways to think about these. So we know overall that vertex form tells us that y equals a x minus h squared plus k. And our vertex is hk. So that's our vertex. So if I think about the overall, r of x, why does it have one x-intercept? Well, it has one x-intercept because I have a 0 there, right? So my vertex is going to be -4, 0. So -4, 0 is the vertex. That means that's on the axis. If I made a sketch of this thing, I'm going to say, well, when I go to sketch this thing, well, -4, 0, here it is. And I can open up. That doesn't matter in this question, but I can see I'm only going to have the one x-intercept, right? So that's it. For s of x, I could look at it and say, well, okay, my vertex is going to be 1, 3. Okay, well, that's not on the axis. What's the problem? Well, let's just take a really quick sketch of this. If I look at that vertex 1, 3, here it is. But which way do I open? Go back to that example 2. Which way did I open? Here, I'm going to open, I have a positive a value. It's implied 1, right? So what that means, I open 1. Well, how many times did I hit the x-axis? How many times do we have an output value of 0? None. So therefore, there's no x-intercepts. Right now, in a solution, that would say, hey, there's no solution because those lines don't hit each other. The probability never hits the x-axis. So there's no x-intercepts, there's no solutions, there's no roots, there's no zeros. Those are, again, that language, slightly different, but the same general idea. Okay, so wrapping this one up, final checklist. So we do want to translate that language. So roots, zeros, x-intercepts, they all involve the output of 0. The way we state them, though, is a little bit different. To solve them, we are going to set that output f of x equal to 0, solve for x using that structure we noticed from video C1. Remember, report them carefully. So roots and zeros are the x values, x-intercepts are the points, x, 0. When you're solving, ask yourself, does that graph touch the axis once, twice, or not at all? And final thing, just connection later on. Be careful when you are solving these questions. So when a question is saying, hey, solve f of x equals g of x, that the answer to that is like a root or a zero. We're going to say x equals da, 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 da. If a question said, hey, find the POIs, points of intersection between f of x and g of x, then we're going to find the x and have to resub for the y. So we're going to say, hey, here's your solution as a coordinate point, just like we would for an x-intercept. Okay, thanks for watching.